Hello students, today we are going to learn gravitation. You know that an object dropped freely from a height falls towards the earth. Planets revolve around the sun and the moon revolve around the earth. For this motion of the object, planets and moon, some force must be acting on it. So Newton called this force the gravitational force. Newton had the opinion that the same type of force is responsible for an object falling from some height towards the earth and also the moon revolving around the earth. The motion of the moon around the earth can be understood with the help of an activity. Take a piece of thread. Tie a small stone at one end of the thread. Hold the other end of the thread and whirl the stone round as shown in the figure. Notice the motion of the stone. We can see the stone moves in a circular path. Now release the thread. And what happens to the stone? When you release the thread, the stone moves tangential to the circle at the point of release. Then what is a tangent? That you must have studied in maths. A tangent is a straight line that meets the circle at one and only one point. So the direction of motion of the stone, it is tangential to the circle. Before the thread is released, the stone moves in a circular path with a certain speed and changes the direction at every point. We have already studied uniform circular motion. An object that moves in a circular path, the speed remains the same but the direction always changes. The change in direction involves change in velocity or acceleration. Where there is a change in velocity, there is an acceleration. The force that causes this acceleration keeps the body moving along the circular path is acting towards the center. And so this force is called the centripetal force. In the absence of this centripetal force, the stone flies off along a straight line. And I told you that straight line, it will be tangent to the circular path. The motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth. Because moon is revolving around the earth. So the earth is at the center. So the centripetal force for the motion of the moon is provided by the earth. Provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. It is only because of that centripetal force the moon is moving in a circular path. In our solar system, all planets go around the sun, isn't it? So there also exists a force between the sun and the planets. From this fact, Newton concluded that all the objects in the universe, they attract each other. And this force of attraction between the objects is called as gravitational force. And Newton concluded that all objects in the universe, they attract each other, isn't it? So that is, every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. And the force is acting along the line joining the centers of the two objects. Because force is a vector quantity, so there is both magnitude and direction. So the direction of the force of attraction between these two objects, it is along the line joining the centers of these two objects. And this is called universal law of gravitation. Suppose there are two objects. Let it be A and B. Let the masses of the two objects A and B be capital M and small m respectively. Let these two objects are separated by a distance d. Let the force acting be F. According to the universal law of gravitation, it is said that the force between these two objects A and B is directly proportional to the product of their masses. Here masses are m and m. So F is directly proportional to capital letter M into small letter m. Mass of the first body multiplied by mass of the second body. And it is inversely proportional to square of the distance between the two objects. So inverse proportion can be shown by 1 upon. So here F proportional to 1 upon d, where d is the distance between the two objects. Combining these two equations, we can write F is proportional to m multiplied by m upon d square. And the proportionality can be changed by multiplying with a constant. Here the constant is capital letter G. So F is equal to G into m multiplied by m upon d square. Is that clear? And G is the constant of proportionality and is called as universal gravitational constant. So this is the formula to find out the gravitational force. So F is equal to G multiplied by m into m upon d square, where G is the universal constant of gravitation, m and m masses of two objects, and d is the distance between the two objects. Now cross multiplying, we get F d square is equal to G multiplied by m into m. And from this we can calculate G by using the formula F d square upon m into m. This is how we can calculate the universal constant of gravitation. And SI unit of G, it can be obtained by substituting the units of force, distance and mass. And the unit is Newton meter square kilogram raised to minus 2, because mass coming in the denominator. When you take in the numerator, we get kilogram raised to minus 2 or upon kilogram square. Otherwise, we can write Newton meter square per kilogram square or Newton meter square kilogram raised to minus 2. The value of G was found out by Henry Cavendish by using a sensitive balance. And the accepted value of G, it is 6.673 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. I hope it's clear to you. Next we can see what's the importance of universal law of gravitation. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. That means the universal law of gravitation helped to explain many phenomena. First one, it helped to explain the force that binds us to the earth and the motion of the moon around the earth. Third one, the motion of planets around the sun and the tides due to the moon and the sun. All these phenomena were explained successfully with the help of universal law of gravitation. What is meant by free fall of an object? We have learned that the earth attracts objects towards it. This is due to the gravitational force. So all the objects in this universe, it is attracted by the earth due to gravitational force. Whenever objects falls towards the earth under this force alone, then we say that the objects are in free fall. So what is meant by free fall then? How can you define free fall? So whenever the objects falls towards the earth under gravitational force alone, no other external force, then we can say that the object is in free fall, or that fall is called free fall, or that motion is called free fall. When any object falls from a certain height, there is no change in the direction of motion of the object. But due to the attraction of the earth, there will be a change in the magnitude of the velocity. And you know that any change in velocity, it involves acceleration. Whenever an object falls towards the earth, there is an acceleration. And this acceleration is due to the gravitational force. And therefore, this acceleration is called acceleration due to the gravitational force of the earth, or we call it by the name acceleration due to gravity. That means any object which is falling towards the earth, there is a change in the velocity, and as a result there is an acceleration. As this acceleration is due to the gravitational force of the earth, we call it by the name acceleration due to gravity. And it is denoted by small letter g. And you remember, capital letter G is used for universal constant of gravitation, and small letter g denotes acceleration due to gravity. And the unit of small g, or acceleration due to gravity, is same as that of acceleration. And you know what is the unit of acceleration? It is meter second raised to minus 2, or meter per second square. From the second law of motion, we have already learned that force is the product of mass and acceleration. That is, F is equal to m into a, where m is the mass and a is the acceleration. And suppose the object that is falling is having a mass m. We know that there is acceleration involved in falling objects due to the gravitational force, and it is denoted by g. So here, as the object is falling towards the earth, the acceleration is due to the acceleration due to gravity. So instead of a, we denote it by g, small letter g. Therefore, the magnitude of the gravitational force F, it will be equal to the product of the mass m and acceleration due to gravity g. So therefore, we can write F is equal to m into g. Let it be the first equation. Here, what is F? F is a force, m is the mass of the object, and g is the acceleration due to gravity. According to universal law of gravitation, we have already derived that F is equal to g into capital letter M into small letter m upon d square. That means universal constant. G is a universal constant. M and m, mass of the two objects. That is equation 2. Listen to equation 1 and 2. The LHS are equal in both the equation. So we can equate the RHS. When we equate the RHS, we get mg is equal to gmm upon d square. Here, mass of the object m is common in both the sides. Therefore, g is equal to capital letter G, capital letter M upon d square. Here, g is the universal constant of gravitation, capital M, mass of the earth, and d, distance between the object and the earth. Is that clear? From this, have we noticed one thing from the equation? G is equal to gm upon d square. That is, acceleration due to gravity is not depending upon mass of the object. Okay, acceleration due to gravity is not depending upon mass of the object. It only depends on universal constant of gravitation, mass of the earth, or if any planet it is, mass of the planet generally if you take, and d is the distance of the object from the planet or from the earth here. And the earth is not a perfect sphere, that we know that. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. So the radius of the earth, it is increases from the poles to the equator. That means radius towards the equator is more than towards the poles. For most calculations, we can take g to be more or less constant on or near the earth. But for objects far from the earth, the acceleration due to gravitational force of the equation, the acceleration due to gravitational force of the earth, it is given by g is equal to gm upon d square. Is that clear? So this is very important, that is, the acceleration due to gravity does not depend upon mass of the object. From the equation it's very much clear. Now, how to calculate the value of acceleration due to gravity? To calculate the value of acceleration due to gravity, we have to put the values of universal constant of gravitation, then mass of the earth, then d, that means d here it is, I told you, the distance of the object from the surface of the earth, that can be taken as radius of the earth. So arc radius of the earth. So by substituting the value, gravitational constant, we know that it is 6.7 multiplied by 10 raised to minus 11 Newton meter square per kilogram square. Then mass of the earth, it is 6 multiplied by 10 raised to 24 kilogram, and radius of the earth 6.4 multiplied by 10 raised to 6 meter. Substituting these values, we get the acceleration due to gravity as 9.8 meter per second square. So this is the acceleration due to gravity on this earth. If you want to find out in any other planet, in place of capital letter M, that is mass of the earth, you can put the value of the mass of that particular planet. For example, if it is Jupiter, so capital letter G, that is universal constant, remains the same. Then if it is Jupiter, mass of Jupiter upon then radius of Jupiter, radius square, r square of Jupiter. So any other planet, you can substitute that values. Okay. Now, see, we have seen that acceleration due to gravity does not depend upon mass of the object. So this means that all objects, hollow or solid, big or small, should fall at the same rate. As g is constant near the earth, all the equations for the uniformly accelerated motion of objects that become valid with acceleration a replaced by g. So we have already learned the equations of motion for uniformly accelerated motion. That is, which are the equations? V is equal to u plus at, s is equal to ut plus half at square, then v square minus u square is equal to 2as. And all these equations, they are valid with the acceleration a replaced by g. Then how it becomes? V is equal to u plus gt, s is equal to ut plus half gt square, and v square minus u square is equal to 2gs. If you want, that s can be replaced by h also because height. Here u and v are the initial and final velocities, where s is the distance covered in time t. And in applying these equations, we will take acceleration to be positive when it is in the direction of velocity. That means the acceleration is taken as positive for the downward motion of the object, and acceleration is taken to be negative for the upward motion of object. Okay?